R2 wants to aim low. Come on, up here. There we go. Okay, here's something to think about while we're running this little mental experiment. We were talking about putting a cell at depth, turning it on, harvesting energy from the lift from the bubbles, and then burning it back to water at the surface. Here on Earth, that works great. We've got, vast reservoirs of salt water, deep. But what if we took it into space? Picture in your mind a massive column of water. I don't know, just a big old tube filled with water. Let's say it's, I don't know, a foot in diameter. We're out in outer space. Nothing else around us. And this tube has in it at one side an electrolysis cell. At the other side it has the apparatus for burning it, engine, whatever. We can theorize on what's the proper way to burn it or convert its chemical energy into electrical energy or whatever it is we happen to be wanting at the time. We can go on for specifics aren't important. You have the apparatus to convert the chemical energy to electrical energy to keep the system running. Okay, so we've got this tube, this great big long, where's the camera? There we go. This great big long tube. Let's see, do I have anything? Okay, here's our space tube. Start thinking 2010: A Space Odyssey. Alright, here's our space tube. Instead of a monolith, we've got a tube. Now let's say we had two tubes. Alright, we've got two tubes. They are exactly the same. They are bound together. Now spin them. Now one great thing about objects in space is they tend to conserve momentum quite nicely. You start spinning these tubes and they'll spin for quite some time. What happens when you spin them? Well, you are creating an artificial gravity. It's an acceleration, which is a change in, the simple version is this. The way physics would explain it to you is you have an object traveling in a straight line with speed, aka velocity. Wow. Alright, R2 wanted to point at my fingers. If that object changes direction, that is an acceleration from this direction in that direction. Something must have pushed it or accelerated it a little bit. That's how you get the gravity, or that's how they explain it, from centrifugal and centripetal forces, all these things. So we're out in space. We got these things spinning. Let's say they're spinning in the water inside the tubes. Let's put some water in there. Let's put, I don't know, KOH in there. It doesn't have to be seawater. It doesn't have to be pure water. It can be KOH water. Let's say 20% normal solution. Sounds great to me. And the cell is at the bottom, and it's an efficient cell, let's say. And we turn it on. It starts making bubbles. The bubbles float, for lack of a better way to explain it. They matriculate away from the acceleration because they are less dense than the water, so the water is actually pushing it. And both of these objects are doing it at the same time. A couple questions. If it creates energy, if you are able to get a COP greater than 1, does your momentum ever change? Would this slow down? Would we just be transferring the stored momentum of these two objects into the water, or would that have no effect? I have my own personal belief on it, but I guess some people should probably contemplate that. And when you consumed or burnt the water, or the HHO, it would go back to water, drip back into solution, and, well, the system just keep going and going and going. What would be the purpose? Well, you could come up with quite a few purposes. Deep space mission. Take a great big ship with a habitat ring, and connecting the ring, you have a bunch of these spokes. these water-powered spokes, and they produce electricity to provide lighting for plant life, which would feed the people, which would be the point of the mission in the first place. You could also power the ion engines, which would only work if you had a fuel source for those ion engines, which you would have a limited amount of fuel, but who knows what you might find while you're out there. Blah blah blah. You could run this out forever, but it is an interesting thought experiment. And like somebody said, if this is the case, then it's all over but the crying. Well, then do the math. I would like to see some other people, do some math and just see if I'm full of it or not. I'm not saying I'm right. I've done the math. I believe that my mathematics was correct. I would like somebody else to do it and see what they come up for an answer. It'd be a kick in the pants. Again, do you live in a 0.5 world or do you live in a 2.0 world? You really can't have it both ways when you can't really live in a 1.0 world. A loose analogy to that, anybody who's ever done stereo systems, subwoofers, or any electrical load, you've got a 4 ohm load and a 4 ohm load. You wire that in series, it's a in series it's an 8 ohm load, parallel it's a 2 ohm load. Notice you can't return to a 4 ohm load unless you eliminate one of the loads. It's similar to that. You either live in a 0.5 or you live in a 2. Think about it. Thanks for the comments, guys. It's fun. I like kicking this stuff around with you. So comment all you like. Tell me I'm full of it. Tell me I'm not. Whatever. Just be prepared. One thing I will tell everybody is I expect everyone to not just give a cursory, well, you're wrong. Okay? If you're going to tell me I'm wrong or tell me I'm got my head up my sphincter, be prepared to prove it. Don't just come up with a comment, because I will be prepared to prove my point. If anybody right now asks me, hey, prove it, I would go to my notebook and I'd bust out all the math, and then you can try and prove my math wrong, which, hey, yeah, maybe I made a mistake. Don't think so. Alright, take it easy. Talk to you guys later.